Hey everyone, and welcome. Today, we're going to go way beyond the simple getting started guides for infrastructure as code. We're not just asking which tool is better. Nope, we're going to get into what it's really like to live with Terraform and CloudFormation long after that first deployment. We're talking day 2 operations.
So let's just jump right in with the most important question you can ask. Which of these tools has a philosophy, a core belief system, that actually matches how your team works? You see, this isn't about a checklist of features. It's about a fundamental difference in how they see the world. And trust me, that perspective changes everything when you're on call at 2 a.m.
Okay, Act 1. This one is the big one. It's all about the source of truth. How does each tool actually know what it's already built? And how does it figure out the difference between your code and what's really out there in the cloud? Honestly, this is probably the most critical difference between them.
And this slide just nails the core conflict. With Terraform, you're holding the blueprint. It's a literal file right there on your machine. You are in control. CloudFormation, it's more like a bank. It keeps a managed ledger of everything for you, tucked away safely inside AWS. So right from the start, it's a battle between direct control and managed convenience.
So let's talk about that file. The Terraform state file, the terraform.tf state, is basically Terraform's entire memory. It's a JSON file that connects the dots between the code you wrote and the actual EC2 instance or S3 bucket that exists in your account. It's your single source of truth, which means you have to manage it, you have to secure it, and you definitely don't want to lose it. And here's where the magic really happens. Before Terraform does anything, you run a plan. And what it's doing is this three-way comparison. What you want to exist, what it thinks exists based on the state file, and what actually exists in the cloud. That plan shows you every single change, add, or delete before it happens, which is, an absolute lifesaver.
All right, let's flip the coin and look at CloudFormation. It couldn't be more different. Here, the state isn't a file you manage at all. It's an abstract idea called a stack. Think of it as a container. You throw all your resource definitions into a template, give it to the CloudFormation service, and AWS just handles it. The state management is completely behind the curtain.
Now, the huge advantage here for day 2 operations is that you don't have to worry about managing a state file. But even cooler is the built-in drift detection. Let's say someone goes into the AWS console and manually changes a security group. That's drift. CloudFormation can actually scan your stack and tell you, hey, what's running in production no longer matches your code. That's a really powerful safety net.
And that brings us to Act 2, the lifecycle. This is what happens when things go wrong. An API call fails, a resource has an invalid parameter, you know the drill. The way these tools handle failure in the middle of a deployment reveals, well, everything about their core philosophy.
And here's the split. I like to think of Terraform as a mechanic working on your car. If they're halfway through an engine swap and a part breaks, they stop, leave everything as is, and tell you what's wrong. CloudFormation is more like a high-tech assembly line. If a single robot messes up, the alarm sounds, and the entire car is pulled off the line and sent back to the start.
Let's walk through that Terraform scenario. You're trying to create 10 servers. Server number 7 fails. What happens? Terraform just stops. The first 6 servers that were created, they're still there, up and running. And importantly, the state file gets updated to show that those 6 now exist. It's now up to you, the operator, to figure out what broke and how to move forward.
CloudFormation? It's a totally different story. Same scenario, 10 servers, number 7 fails. The second it fails, CloudFormation automatically triggers a rollback. It will systematically delete the 6 servers it just successfully created, returning your entire stack to the exact state it was in before you started. It's all about safety and predictability, with zero manual cleanup. So you really have to ask your team, what do you value more in a crisis? Do you want the fine-grained control to jump in and fix a partial failure mid-deployment, or do you prefer the ironclad safety of knowing that a failed deployment will never, ever leave your system in a weird halfway state?
Okay, moving on to Act 3, let's talk about the code itself. The choice between Terraform's HCL and CloudFormation's YAML isn't just about curly braces versus indentation. The language itself is an engine that fundamentally defines how dynamic and complex your infrastructure code can be.
This is such a cool distinction. Terraform's HCL is what we call graph-based. That's a fancy way of saying it automatically understands the relationships between all your resources. It builds a dependency graph. CloudFormation's YAML is more linear. You have to be much more explicit and often spell out those relationships yourself.
And you can see it right here, clear as day. In Terraform, if I want 3 S3 buckets, or 30, I can use a for each loop. It's just a few lines of code. To do the same thing in CloudFormation, I literally have to copy and paste that resource block 3 times. Now imagine you need to scale that to 50. That difference in dynamism is a massive deal for day-to-day operations.
And it goes way beyond just loops. Terraform gives you this huge toolbox with over 100 built-in functions for manipulating strings, doing math, whatever. In CloudFormation, sometimes you have to jump through some pretty wild hoops. A classic example is needing the current date. Sometimes that means you have to write, package, and deploy an entire Lambda function just for that one little thing. HCL just solves that out of the box.
Okay, for our final act, let's pull the camera all the way back. Because your infrastructure isn't just AWS, right? You've got DNS providers, GitHub, monitoring tools, all sorts of things. How each of these tools defines its boundary of control is the last major piece of our puzzle.
I absolutely love this metaphor. Terraform's goal is to be the universal translator from Star Trek. If a service has an API, there's a good chance Terraform can talk to it. CloudFormation, on the other hand, is a native dialect. It speaks AWS absolutely perfectly, with a flawless accent, but that's the only language it knows. So how does Terraform do it? The secret sauce is this concept called providers. A provider is just a plugin that acts as that translation layer. There's an AWS provider, a Google Cloud provider, a GitHub provider, even a Domino's pizza provider. This is what lets you manage your entire, complex, multi-vendor stack with a single tool and a single workflow. But, and this is a huge but, you should not underestimate the power of being native. If your company is all in on AWS, CloudFormation is seamless. When AWS launches a cool new service, it almost always has CloudFormation support on day one, while the Terraform community has to play catch-up. Plus, having your ISC tool covered under your main AWS Enterprise Support plan, that is a massive, massive win for a lot of companies. So, there you have it. We've gone through the 4 acts: how they handle state, what they do when things fail, the language you write, and the boundaries they operate in. Let's wrap this all up by framing the final choice not as which tool is better, but which operational reality do you actually want to live in? This table really says it all. You can see the pattern, right? Down the Terraform column, the theme is user-managed control, flexibility, and a wide reach. Down the CloudFormation column, the theme is service-managed safety, consistency, and deep native integration. There really is no right answer here. It's just a series of very important strategic trade-offs. And that's really what it boils down to. You're choosing between a super versatile, totally agnostic toolkit that can plug into just about anything, and a seamless, perfectly integrated, native extension of the AWS platform itself. Both are incredibly powerful and completely valid ways to build and manage modern infrastructure.
So that's the question I want to leave you with. Think about your applications, your team, your whole operational philosophy. Are you a mechanic, carefully orchestrating a collection of distinct parts with a powerful universal toolkit? Or are you more like a factory manager, building a seamless extension of a single powerful platform? Your answer to that question will tell you which of these tools truly thinks like you do. Thanks for tuning in.